This is Rama, Botany, and welcome to the webinar session 5. Today, we are going to discuss the mechanism of enzyme action. In our previous classes, we discussed about the characteristic features of enzymes and their classification and nomenclature. And after that, today we are discussing about the mechanism of enzyme action, how the enzyme shows their effect on the substrates molecules during the reaction. And this mechanism is explained, this mechanism is of two types. There are two theories in explaining the action of enzymes. One is lock and key theory. The second is induced fit theory. First one is lock and key theory. And this theory was proposed by scientist Fisher. Fisher proposed this theory. And here in this heading, we can understand one thing, lock and key. Usually we use this locks. And it's a related key only opens the lock. The same sense is given in explaining the enzyme action by Fisher. And this lock, who will work as lock, means enzyme here, enzyme acts as a lock. And key, substrate molecule, that means as per the shape of this enzyme reaction taking place, substrate molecules will be selected. As per that, the shape of this active sites, substrate molecules are selected and to fit in the active sites. So here substrate molecules, they act as key. They plays the role of key. So based on this thing only, Fisher given this name lock and key theory. So in this, according to this lock and key theory, the structure of enzyme that acts as a lock and a substrate molecules, which fits into this active sites, they plays the role of a key. And to understand this, if we observe the structure of an enzyme molecule, here it is an enzyme molecule, and this enzyme, it is in the shape of a molecule, and it is having some notches, some grooves, some depressions. So we can use any word, either it is a depression or a notch or a groove. And these grooves or notches are surface of this enzyme. And these notches, they are called as active sites. So here, 1, 2, 3 active sites are there. And related to this shape, substrate molecules are selected. Substrate molecules, they resembles the shape of this active site. So here, the substrate molecules, they are in related shape of the active site. Okay. Now, we have discussed characteristic features of enzyme. In that, one point was discussed, and that is enzyme molecule is larger than the substrate molecule. So here we can see that point. We can observe the point. This enzyme molecule is a little bit larger than the substrate molecule. And this substrate molecule that comes and fit in this active sites. So depressions are the active sites into which substrate molecules are going to fit in this active site. So this substrate molecule that comes and fit in this active site. So according to lock and key theory, which was proposed by Fisher, what he said is this enzyme that acts as a log, and this substrate molecules which resembles the shape of the active sites on this enzyme fit into this active site. So here the substrate is acting as a key to fit into this active site. So, according to Fisher, this was explained. The next, yes, according to that, substrate molecules. To explain this lock and key theory, we are taking two substrate molecules. Here also, we have taken one or two, three substrate molecules. Here, three active sites. And the same was given here. Substrate molecules are here, and the enzyme molecule is there. So, these two substrate molecules, they fit in this active site of the enzyme. And here, what happens is active sites of enzyme and the substrate molecules, after fitting into this active site, they togetherly makes or they togetherly uh, uh, develops a complex, which is called as enzyme substrate complex. That means after inserting this substrate molecules into the active site, they both the enzyme and substrate both together makes a complex by framing the bonds, where temporary bonds between the substrate molecules and enzyme molecules are active sites. They together makes a complex, which is called as enzyme substrate complex. And here, basically what happens here means active sites of enzyme and substrate molecules makes togetherly a bond with the active sites, and that is specific. As we discussed in our previous classes, there is a specific substrate and specific enzymes. That means enzymes are have specificity with the substrate molecules. That means all the enzymes, they do not show effect on all substrates, or all the substrates do not reacts with all enzymes. There is the specificity. Enzyme and substrate specificity is there. So, for example, carbohydrates. On carbohydrates substrates, only amylases shows their effect. That means that this substrate have a specific enzyme. That means the specificity is there. According to that specificity, this substrate molecules, they comes and fit in the active site of the enzymes, and they makes the bond with the active sites. And this is very specific. So based on this only, by utilizing this specificity, this specific substrate can make a bond with the specific enzyme, and as a result of this, a temporary substrate complex will be developed, and that complex is called as enzyme substrate complex. So here these two are substrate molecules, and this is enzyme, and here this notch is an active site. So substrate molecules, two substrate molecules are taking part in the reaction, and they come and sit in the active site, and by maintaining the enzyme and substrate specificity. So based on that, the substrate molecules, they bonds, they makes a bond with the active sites, and gives a complex, which is temporary, and that complex is not a permanent. So this temporary complex is called as an enzyme substrate complex. Okay. Then after framing, after developing this complex, they undergoes a reaction, and this reaction results in the formation of end product and enzyme separately. That means there's further reactions results in the development of again enzyme without any change and an end product. And this end product, this substrate molecules, they are connected with one another. That means during this temporary substrate complex stage, this substrate molecules, they bonds with one another. They combines with one another. They reacts with one another and gets a bond between them. That means both the substrate molecules are attached with one another. By that, a new product will be produced by this enzyme reaction effect. So, at the end of this reaction, or at the end of this chemical reaction, enzyme comes out as it easily without undergoing any change, and the substrate molecules, they by combining with one another, they results in the formation of a new product. So in this way, this Fisher, he explained Fisher explained log and key theory. That means based on the enzyme substrate molecules which related the shape of active sites comes and fit in this active sites, and after that, this substrate molecules, they makes a bond with the active site of the enzyme and gives a temporary enzyme substrate complex. And this complex, furtherly by undergoing reactions, gives a enzyme acetylene and a new product. And this new product is developed by the bonding or by the joining of a substrate molecules with one another. This end product will be produced. So here, this enzyme, it is coming out as it is without undergoing any changes. As I discussed in a characteristic features of enzymes, we discussed one point that enzymes, they comes out as it is they are recycled and reused. Yes, based on that point, we can say that this enzyme, it is coming out at the end of the reaction as it is without undergoing any change. So that was proved. So as soon as both the substrate molecules comes closure, bond formation takes place between S1 and S2. See here, between S1 and S2, a bond is framed or bond is developed. And this is a temporary bond and dissociates easily and gives the product and enzyme without any change. So here, this complex, it is temporary, and in further reactions, the enzyme that comes out as it is and the substrate by undergoing chemical reactions, both the substrate molecules joins together and gives the end product. So substrate 1 and 2, now they have attached with each other and by bond formation, and furtherly they are called as end product. And this was explained just now only. So here what we have to understand is based on the shape of the active site, substrate molecules are related what this shape, based on the shape of this substrate molecules, active sites of the enzyme selects the substrate molecules, and the substrate molecules comes and fit in the active sites of the enzyme and gives a temporary complex which is called as enzyme substrate complex. And by undergoing further reactions, so this enzyme is that comes out as it is without undergoing any change, gives the end resulting the end product. And this end product is the final product of the association of two substrate molecules. So this whole thing was explained by Fisher, and that theory is called as log and key theory. The next theory is Induced fit theory. Induced fit theory. See here, induced fit theory. Right. And this theory was proposed by Koshland, scientist Koshland. According to this, and every enzyme has two active sites. It is little bit different from the lock and key theory. In lock and key theory, there is only one active site. That means same type of active site. Only one active site is there. But in this induced fit theory, each and every enzyme has two active sites. And one is catabolic site, the other one is catalytic site, the other is buttressing site. So each and every enzyme has two active sites. It is the characteristic feature of induced fit theory, which was proposed by Koshland. And if we observe structure of an enzyme, that will be in this way. See, this is one enzyme molecule, and it is having two sites. This site, transfer site, is called as catalytic site, and this longitudinal site is buttressing site. So each and every enzyme has two sites, two active sites. One is catalytic site, and the other one is buttressing site. And substrate molecules, which participates in the reaction. The next, here, how the reaction takes place, and what are the functions of this catalytic site and the buttressing site. Catalytic site that helps in breaking the old bonds and making the new bonds. During the reaction, this catalytic site that helps in breaking the old bonds between the substrate molecules and making new bonds between the substrate molecules. The next, buttressing site. What is the use of buttressing site? This longitudinal buttressing site that helps in giving the site for substrate molecules. Yes, in lock and key theory, only one site was there, and on that site is active site, and in that active site only substrate molecules come and fit in that active site, and there only reaction takes place, or complex first initially temporary complex will be framed, and which furtherly undergoes reactions and gives the end product. That is a matter. That is about the lock and key theory. But here in induced fit theory, each enzyme is having two sides. One is helping for breaking of bonds between the substrate molecules and then creating new bonds between the substrate molecules or end products. Then buttressing site, it is helping in receiving, or it is giving the place for substrate molecules to come and sit on that places or under the sites. So, and this buttressing site is helping in giving the site for substrate molecules. The next, here, as we said, that substrate molecules binds with the buttressing site. See here, diagrammatically, here, this is a catalytic site, and this longitudinal is buttressing site. And this buttressing site, it is giving the site for substrate molecules. They come and attach with this buttressing site. So here, see the substrate molecules. They came and attached with the site of this buttressing site. Okay, so B site means buttressing site. In this way, here, this enzyme with substrate molecules gives a temporary complex. That is enzyme substrate complex. So here the enzyme substrate complex is developed. And this complex is temporary. It is not permanent. It is temporary complex. And this temporary complex uh, uh, that furtherly shows the changes in giving the end product. But before that, before the forming this enzyme substrate complex, there is another change that takes place during this reaction. So one more stage is there before the formation of this complex. This means at a butter side, there is an important change. And what does that means? The change is enzyme undergoes conformational change. That means before the formation of this temporary complex, one conformational change will be taken by one side. That means the shape of the enzyme molecule is changed, and that change is that catalytic side comes very closer to the buttressing side or substrate molecule. See here, it is in the shape of L. And after the attachment of substrate molecules to the buttressing site, this catalytic site that shows uh, what is that change in their position. That means conformational change, change in their position. That is conformational change. So this catalytic site that bends towards the substrate molecule that is shown in this diagram. See here, this is the buttressing site. It is as it is only. But this catalytic site that is extending towards the substrate molecules, that is coming closer to the substrate molecules. This change that happens before the formation of the complex. By this, what happens? Here, just now only we discussed. What is that? This catalytic site that helps in breaking the old bonds and making the new bonds. So, as per this statement, a bond is developed between the substrate molecules by the influence of this catalytic site, which is coming closer to the figure. And this substrate molecules are separate in this diagram, which are attached to the buttressing site. And this catalytic site, it is coming closer to the substrate molecules. And by the influence of this catalytic site, a new bond is created, a new bond is developed between the two substrate molecules. And this new bond creation is by only catalytic site. So, as a result of a catalytic site, new bonds are developed or created between the substrate molecules which are attached to the buttressing site. The next, so here, point is what is the point means before the formation of this complex, there is one more important change is there. And what is that means? That change is enzyme that undergoes conformational change, especially catalytic site that shows change in its place. That means the shape of the enzyme molecule will be changed. How means that change is catalytic site that comes closer to the buttressing site or substrate molecules. That means catalytic site that bends towards the substrate molecules that comes closer to the substrate molecules. By the influence of this catalytic site, a new bond is created, new bond is established between the substrate molecules, and after that, a new complex is developed. So, function of catalytic site is breaking old bond or creating new bond between uh, uh, the substrate molecules S1 and S2 are more than that substrate molecule. So, as soon as S1 and S2 joins together, a new substance is formed, which is called as product. That is the next point. But before that, this catalytic site that helps in creating new bond between the substrate molecules. Uh, so, according to the induced fit theory, here this substrate molecules are induced or introduced to this buttressing site, or the substrate molecule they comes and attach with the buttressing site. Why means to undergo the chemical reaction. And use of catalytic site is this by showing the conformational change. This catalytic site that helps in creating new bond between the substrate molecules. As per this fit theory, catalytic site is helping in creating new bonds. Before that, there is no connection between the substrate molecule. But after this bending of catalytic site towards the uh, substrate molecules, it helps in creating new bond between the substrate molecules. So here, after developing this bond, a complex is developed, which is called as enzyme substrate complex. So after undergoing this conformational change only, complex will be developed. And this complex that is temporary. Uh, this complex is temporary, and furtherly this complex that undergoes changes and gives the end product. So here enzyme that undergo by undergoing conformational changes, that means a change of enzyme molecule takes place, and that change the catalytic site that comes closer to the buttressing site or substrate molecule. Okay, the next, as soon as this bond is developed between the substrate molecules, they furtherly gives the end product. Okay, along with the enzyme, they comes out as the end product of this reaction. Now here, buttressing site is not the site for attaching the product molecules. Product molecules, they are coming out here, but not attaching with this buttressing site. That means after developing a bond between the substrate molecules, they are they get detaches from the buttressing site, and they comes out independently, or they comes out freely as the end product. And this enzyme that becomes free without any substrate molecules. That means again it regains the it regains its original shape, and again it is ready to participate in the reaction. So here what we have to understand is, in induced fit theory, what the important things are means, in induced fit theory there are two types of active sites. One is catalytic site and the other one is buttressing site. Catalytic site helps in creating new bonds or breaking up bonds between the substrate molecules, either developing or breaking up bonds between the substrate molecules. And buttressing site, especially, it is helping in giving the site, or in providing the site for the substrate molecules which undergoes chemical reaction. So two types of active sites are uh, introduced in this induced fit theory, which was proposed by Koshland. And next, substrate molecules, after joining with the buttressing site, usually the forms or develops a temporary enzyme substrate complex. But before this, getting this substrate enzyme substrate complex, there is another change which was not observed in lock and key theory. Only that is observed in the induced fit theory. What is that means? That is enzyme conformational change. That means shape of the enzyme will be changed, or site of the enzyme will be changed according to the reaction. And how means, after attaching this substrate molecules to the buttressing site, this catalytic site that shows bending, that comes closer to the substrate molecules by bending its position, or by changing its position. So after coming closer to the substrate molecules, this catalytic site influences a new bond framing between the substrate molecules. As a result of that, this conformational change, a new bond is created between the substrate molecules. So after this bond formation, they gives the temporary enzyme substrate complex. After showing this conformational change, and this conformational change, two things happens. One is this catalytic site that comes closer to the substrate molecules, and the second is this catalytic site influences new bond formation between the substrate molecules. So by after completing this conformational change, a complex enzyme substrate complex will be developed, and this complex, yes, catalytic site is what is the use of this one? After that, as soon as S1 and S2 joins together, a new substance is produced, and which is called as a product. Then buttressing site is not the site for attaching product molecules. It is not the site for attaching the product molecules. It is the site for only substrate molecules which undergoes a chemical reaction. So that is only given here, but this buttressing site is not the site for the attachment of a substrate molecule. As soon as product is formed, it leaves the buttressing site and becomes a free product. And enzyme also becomes free. Buttressing site, after leaving this product, buttressing site, this enzyme becomes free and it regains its original shape. Initially, how it was, it is like this. See, so after undergoing reactions, after giving the products, this enzyme is coming out as it easily. It is coming out as it easily without undergoing any change. It is regaining its original shape, and the end product is coming out. This end product, initially, product molecules are separate. Look at the diagram. Here they are separate, but after undergoing reactions, a bond is created between the substrate molecules and they became together. And after that, these molecules are treated as products, end product molecules. And this end product molecules, after leaving this buttressing site, they becomes free. And enzyme also becomes free and it regains its original shape. That's why at the end of this enzymatic reaction, substrate molecules are converted into product molecules, but enzyme, initially how it was, it is as it is after the completion of the reaction also. So this is about the induced fit theory. Here, inducing, what we are inducing here means substrate molecules are induced. Induced to whom? They are induced to buttressing site of the enzyme. So this is about the induced fit theory, which was proposed by Lang. And there are some differences between the lock and key theory and the induced fit theory. What are those differences? In both the cases, enzyme and substrate complex is developed, which is a temporary stage. But in induced method, enzyme has two sides in which catalytic site is helping in making new bonds between S1 and S2 and a product is developed. That means in lock and key theory, there is only one complex, that is enzyme and substrate complex. Only one complex is developed during this reaction, and complex is only one only, but sites, active sites are only, complex is only. But for making that complex, there is only one active site in lock and key theory. Whereas in induced fit theory, there are two active sites. That is the main difference. And that is catalytic site and the buttressing site. Both sites are there on a single enzyme in induced fit theory. Whereas in lock and key theory, there is only one active site which helps in receiving the substrate molecules and developing the complex temporarily. Here also, complex is developed temporarily, but there are two different sites, which are one a catalytic site, the buttressing site. And one more difference is in lock and key theory, there is no conformational change of enzyme. There is no structural change in enzyme in lock and key hypothesis. Whereas it is observed in induced fit theory. There is a conformational change in enzyme. That means this catalytic site that comes closer to the substrate molecules in influencing the creation of bond between the substrate molecules, which are attached to the buttressing site. So that is another difference in this induced fit theory, which is present and it is not present in lock and key theory. So this is one more difference between the lock and key theory and the induced fit theory. So based on this, we can we can understand the enzymatic action. So in the mechanism of this enzyme, there are again two theories. One is lock and key theory, which was proposed by Fisher, and second is induced fit theory, which was proposed by Postland. And according to this lock and key theory, this complex, that means related enzyme and related substrate molecules comes in contact with one another in proceeding the reactions. So these sites, which are called as active sites, are only one type of active sites are present in lock and key theory. According to this active site, substrate, specific substrate molecules, they come and attach with the active sites in framing the complex temporarily, which is called as enzyme substrate complex. And this enzyme substrate complex furtherly that undergoes reactions and helps in giving the product molecules and enzyme as it is. And this enzyme that comes out as it is without undergoing any change in its structure or in its nature. So there is no change in its structure of enzyme. Whereas product molecules, they combine with one another, they are joined together and making a new product or new end product. So this is about the lock and key theory. And whereas in induced fit theory, there are two important differences between this induced fit theory and the lock and key theory. In induced fit theory, enzyme is having two sides. One is catalytic site, the other one is buttressing site. Catalytic site helps in creating new ones or breaking the old ones between the substrate molecules. Whereas buttressing site only purely it is meant for attaching of substrate molecules or giving the place for substrate molecules which undergoes a reaction. So here, this buttressing site that helps in giving the position or site or place for the substrate molecules which takes part in reactions. So in induced fit theory, we can see this difference that enzyme is having two sites, catalytic site and buttressing site. And substrate molecules, they may participate as per their requirement. That means more than 2 or 3 or number of molecules can take part in this reaction. So substrate molecules, here we are showing 1 or 2 substrate molecules. And this substrate molecules, they come and sit on this buttressing site. That means they are attached, they are connected with the buttressing site. And what is the function of a catalytic site? Now, there is no job for this catalytic site during this situation, and there remains quite after the attachment of substrate molecules to the buttressing site, they react. In what way they react? That means that they gradually bends, this catalytic site gradually bends towards the substrate molecules. Like this in this diagram. See here, these are the substrate molecules and this enzyme catalytic site that is showing bending towards the substrate molecules. As a result of that, this site that comes very closer to the substrate molecules, and by the influence of this catalytic site, a new bond will be developed between the substrate molecules. That is shown here, a new bond. It is created as a result of the effect of this catalytic site. And this bond is connecting substrate 1 with substrate 2. As a result of this bond, a new material, a new substance will be developed, which is called as product, end product. So here, before the formation of this complex, we are observing the conformational change. We are observing the conformational change. That means change of position in catalytic site, and that is most essential in this induced fit theory. So, in both the cases, enzyme substrate complexes in both the cases, in lock and key theory and in the induced fit theory, in both the situations, we are observing the formation or development of this complex, which is temporary, and furtherly that undergoes various reactions and results in the formation of two end products. Those are one enzyme and the other is end product. But here, enzyme again it recuperates its original shape. The next end product that comes out as it comes out with a new texture or new nature. So this is about the induced fit theory, and tomorrow we'll continue the class. Till then, thank you.